Okay, for question 2c, we're using the values of the second derivative at each of the stationary points to decide their nature. So what it's really asking when it says to decide their nature is we want to know if they're maximums or whether they're minimums. Okay, so before you start, really, you need to know that if your second derivative is positive, that's going to imply it's a minimum, and if your second derivative is negative, that's a max. So that there is your prior knowledge, really, and if you don't know that, you won't be able to answer the question, so make sure that's something in your mind. From part 2b, we found out that the derivative was 2 minus 2x to the power of negative 2, so we need to use that, so hence that's written down here. Right, let's start with the question then. So we're going to find the second derivative, so if we write that down here, and then 2 is going to disappear. Negative 2 times negative 2 is 4, and then decrease the power by 1. We can rearrange that a little bit just to make it look nice, and then put the negative 3 on the denominator. So the second derivative is 4 over x cubed. Okay, so each of the stationary points, let's take the first one. So at x is 1, 4, that implies, and don't let this confuse you, you've been given the coordinates here x, you've got x and y. You don't actually need the y coordinate to work this out. So yeah, don't let that confuse you. Anyway, so we're going to substitute the 1 in. So we've got 4 over 1 cubed. So 1 cubed is obviously 1, so 4 divided by 1 is 4. 4 is clearly greater than 0. So going back to our prior knowledge, if you've got a positive number, it implies that at 1, 4 it's a minimum. And likewise, we've got now at negative 1, negative 4. That implies we're going to substitute that back into this. So we've got 4 over negative 1 cubed. Negative 1 cubed is negative 1, so 4 divided by negative 1 is negative 4. That is now less than 0, and again, that then implies that's a maximum. And that's your question done.